We now welcome Mathias Wien from RWTH Aachen University, and he's going to deliver a talk on methods and metrics for visual quality assessment and MPEG standardization. Thank you, Mathias.
Okay, thank you very much. Thanks also for the invitation to give me the chance to talk about these things. Make it very quick. So we brief what I'm going to talk about is I just talk a little bit about how MPEG works. I think that may be helpful. It's about standardization, meaning that we want to produce a bit stream that comes out at the same thing always. So we heard about this topic about the macroblog issue. That shall not happen, right? So we're striving not to have that. I talk a bit about where we do visual quality assessment in the process. And then I do present you briefly two studies that we did on quality metrics and quality assessment by subjective assessment. And we see there are interesting observations about these kind of things. And finally, I talk about our new data set that we are preparing, CVQM, where we want to go a bit deeper into these kind of aspects. So how does MPEG look like? This is the subcommittee 29 of the ISO IEC JTC1. It's a very complicated structure. You don't need to go into it. You have 8 working groups, 5 advisory groups. 10 out of those groups are MPEG, and the quality assessment is down there. That's well, we are the highest number of advisory groups. Let's put it this way. I think we're quite active there, and yeah. So this is just forming it. We have MPEG does not only do video; it also does audio. It also does genome. It does many things. A lot of systems stuff. I think all devices in your pockets will have multiple MPEG technologies inside. For 85, just quickly, I have 5 focus groups which try to cover the areas that we have. So means SDR video would be like just regular stuff. HDR, of course. We have one group just focusing on metrics, immersive video, layered video. Just because we have so many different aspects, we have people assigned to that. Not going too much into it, but just telling you that MPEG is active. Media coding is the red stuff over there. I think that's something like 11 or so activities going on right now. And then you have systems and other stuff. These are standardization projects. There's a link. If you go to mpeg.org, you can just also find these slides. I don't want to. It's very full. The one that's maybe for people working in the video domain, which is most interesting, is the one where is it? Enhanced compression beyond VVC capabilities. It's a tiny one of those tiny little arrows that may turn into something red within the next year and a half, let's say. And that would be a successor for VVC, so a new big standardization effort. And that's something that will be very interesting to go to. Very quickly, if you have these groups, then there is there are terms of reference what it is, and I don't want to read them out. It's just there's a lot of specific items that we are tasked to do, specifically in the context of preparing calls for proposals. That would mean the start of a standardization projects. Typically, we start with a call for evidence, which is also, oh, you don't see my mouse, right? Which is also shown here. So these kind of things, evidence is collected before we do a standard, typically, because we want to know that if we call for something, then we will get a response, right? So testing if there's something. And there's many other things like that. So we are about to collect data, maintain databases, host the test material, also recommend how to work for laboratories, and also for the groups and liaise with other organizations. That's basically what we do. So a full list of things that are supposed to be done. Now let's walk a little bit through the standardization stage. We start with the call for proposals. So that would be the kickoff for an standardization phase, where it's about basically sorting the proposals which are competing. Yeah, that's the competitive stage of the standardization process. And the idea is that we try to identify which of the proposals would be best. There are many dimensions for that. So, I mean, you have complexity, you have all these kind of constraints. But the topic that we are interested from the AG5 perspective, from visual quality analysis, is, or the assessment is the subjective quality. So there's a lot of work going into how to do that, how to set up the test so that it's meaningful, right? And that's very important because we need to somehow have an idea, what is the expected compression gain that you have compared to the old technology, so that if we select bit rates for the tests, we don't have the new technology running to saturation because it's just transparent, because then we could not differentiate between different proposals anymore. But it cannot also be too challenging because then we may receive a lot of crap. And then the poor subjects who are running the subjective tests will just see stuff that they wouldn't like to look at, and that's also very annoying. So there's a lot of things of that. So we prepare that, we produce the test results, and then we report to the group, who would then hopefully be able to draw a decision saying, okay, so this is the best technology that's around, and so then this would be the test model. And well, subjective quality is one of the most important things because it needs to run, and the other aspects, of course, have to wait into. Right? We already did within the new structure of MPEG. We did some, right? So we have dynamic mesh coding, AI-based point cloud coding. Those are the two that are already completed. Lenslet video coding is the one that's going to be completed in the next, let's say, half year, roughly. And then I made it in blue because the decision on that thing is going to happen in January at the next meeting of JVET and MPEG, where probably there will be a kickoff for a new standardization activity. And then, if that happens, I'll probably start reaching out to laboratories also who might want to be part of the evaluation activity. Because so last time, I think we had something like 35 proposals. If you have something like, let's say you have 10 sequences for rate points, maybe 2 coding configurations times 35, then you have a rough estimate of the amount of testing that's going to be needed. That will be massive. And so this is it's a big activity that we are going to look at. And once it's kicking off, we will start preparing for the big event. So what do we do? That was the CFP, right? So what do we do next? We're supporting the work during the standardization development process, and that's supporting decision making. And that has already been done before, so it's not like we are inventing anything, but it's something that we are formalizing it maybe a bit more. And there have been specifically a lot of activities if it comes to things like adaptive loop filters, deblocking filters, things like that, where traditional metrics simply don't work, right? So you have a change in the technology, and it's about really, this is about decision making. So you have, let's say, 2 versions of deblocking. Do you like it sharper? Do you like it softer? How do you like edge cases to be treated? All these kind of things. That's something that you typically cannot do with a metric, unless you spend a lot of time developing a metric for this specific purpose, and then the world has gone on. You have a different coding scheme, and it doesn't work anymore. Yeah, so there's a lot of visual testing that needs to be done, and typically it's involving procedures so that people submit bit streams. It's somewhat cross-checked, and then we do tests, and we do that actually typically also on site. I will talk about that in a minute. And what we also do, determining performance status of the projects. So I just want to show some slides that we did produce in April this year. This is so we have the bit rate, so kilobits per second. Basically, this is one example sequence. We have the MOS. In MPEG, we are very fond of using the scale which has 11 grades, right? Typically, people like the 5 more, but 0 would be crap, 10 would be transparent, right? So this is the scale that we use. And we see the orange curve is the VPM is VVC, so that's the state of the art currently. And we have quite some nice improvements over that curve. So that's a nice curve, right? And you see 2 variants. The ECM is the exploration model. And we have ECM in dark blue, and then ECM in a different version, NTM, which is similar, right? Now what we see is in this curve, and even more drastically in this curve, we see that the performance is very, very different, right? And those numbers, the curves for the PSNR and the curves for the MOS do not match. Yeah, this is not something that has been indicated before. And this is a significant issue. Yeah, because people typically do, so in the process, you have always, like you rely on some metric. In MPEG, it's typically P/R, which is, I would say, it's not totally bad, right? And because otherwise, things would never have gone so far, right? Apparently it seems that like things like AVC, HEVC, VVC, all these things, they have been working, right? And all the decisions were done on P/R, but sometimes it really fails. And that's something which is super important to have in mind. Yeah, so sometimes the numbers are simply wrong, right? So this is something that's very important. How do we do that at the meetings? Actually, we typically want to do it kind of live. So people have to bring their videos. The data has to be checked, everything before. We set it up at the site. These are two examples where we actually had quite good conditions in Wien and in Kema in Turkey just a couple of weeks ago, where we had, so in Wien we had 4 65-inch screens, OLEDs. In Turkey we had, this is an 85-inch screen, and then we had 4 screens like set up in a cube. Because of the room conditions, we had to do it in this way. And we typically try to have, so we set it up, we have a PC brought there, which can play the raw video live out. So we really we develop everything on the stage. We run it within, let's say, 1 or 2 days, and then we get the results and we report that back to the group. And that's very helpful, right? So typically we have something like, so in this setup with 4 screens, we are able to produce, let's say, 60 rate points evaluated within roughly 2 hours. This is a really nice result. And we are doing some improvisation there because we get into some room that has some properties and we have to deal with that. But it's typically it works out pretty well. And in Turkey, we actually had a cinema room that we could use. So black walls, right? That was pretty nice. But of course, you have to always see how the displays are, and you have to accommodate a lot to do these kind of things. So that's something that we do in physical meetings as a regular operation. Another thing that I just briefly want to touch on is verification testing. That comes after. So we were at the start, we were in the middle of the process, now we are at the end, where it's about to check out if the performance that was claimed is actually received. We did a bunch of those, including VVC, of course, LCEVC, EVC, but also other things. For example, immersive video, MIV, that's the one that's just shown for the curves. Where you typically, the result that you want to see is like you have a reference to the technology that was there before, and you get some significant improvements depending here. So you here see the red one is the new one, and which would reach transparency where the anchor would not do, and here for this case it's even earlier, depending on what you see. This is kind of the messages that would be intended. We are working on more of that. Actually, I mean, VVC has been out since a while already, right? And we are still working on verification tests, right? So it's sometimes not easy to also get companies contributing at the pace. It's much easier if you want to do something new than doing something for verification. Film grain is almost closed now for quite a things. If you want to look into the JVET documents of the last meeting of Kema, we had some very nice results that were produced there. We do give some guidelines, right? This is something that, so we did some actually in the context of, well, the pandemic situation, which was a bit awful for us because it's about viewing and how do you view if people are separated in their offices or maybe at home. So we did remote expert viewing. I'll talk about this a little bit. Typically, that was something like A/B comparisons. So we wanted to have a comparison. Is a tool better or not? And if it's about tiny differences or small differences, then this kind of comparisons, of course, are more suitable. We have more guidelines. One is on verification testing, which is basically meant to clarify what we are supposed to do, because sometimes people may have different opinions on what needs to be done or how it should be done. And so one typical thing is we do not do a verification test on the common testing sequences, right? So not something that we have been optimizing for 10 years, And then we say, oh, look, if you look at this point, it's our sweet spot, and by chance it works. Right? So we need to have something that's coming fresh from the outside, proving that the technology really delivers what it's supposed to be delivering. Right? Okay, and this leads me to the first study, which is on the REV. Right? So remote expert viewing. So what was done there? We took 6 remote expert viewing tests that we did in JVET. Those were all doing this comparative thing, A/B, and somewhat historically driven, but we went for a forced choice testing there. So you would have sequence A, sequence B, and it could be much better, or worse, or much worse. Like those would be the 4 values, but you could not say they are alike. Yeah, so the people in the test were forced to decide if they would be positive or negative on something. One argument about that is we are talking to experts. So we say, Guy, you have to have an opinion, right? And that's one thing, right? So you need to decide. And if the group is large enough, it would somewhat balance out, right? So we took this data, then we did a laboratory test on a subset of those sequences. You can't read this on purpose. I just want to say that there's a lot of data. And so the things that are bold are points that we selected for the testing. There's a paper on that where you can look up all the details on these kind of things. But we took some cases which were like clearly different. We took some that we would consider to be difficult. So like we did a subset of what we had as an input from the REV, just to have a good selection. And then we ran those tests. This is just a summary. So we had 31 viewers in the laboratory. That were students from our university. It's actually being at the university is a super source, because if you have a course like I'm doing a bachelor course now, where we have 900 registered students in the beginning, in the first year. It's a big university. So if you call and say, I need subjects for a test, and you get a little bit of money, it takes you half an hour, and you have your subjects. Right? So excellent thing. And so this is just a comparison to see how different this is. The basic point is, for the REV, we don't have control over what the people do, right? I mean, it's experts, so we say, guys, you're experts, you have to know how to set up your screen, but we cannot verify if they were able to do that. And we don't know if they were like doing some laundry while watching, or if they were sitting in a quiet room, really focused on tests. All these kind of things are not known to us, so there's some noise factor. But since it's not crowdsourcing, right? It's a very different topic. For crowdsourcing, I think it's a real challenge, because people would do that for the money that they would get. While here, it's experts who should do that for their job, right? So we hope that people were behaving well. Okay, so we acquired that data, and now the question is, how do we assess that? We have the REV, which is doing comparison category rating, right? CRR. So we get a comparative MOS value out of that. For the laboratory, we do a comparison to the original. We do a DCR test. So we show the original sequence, and then we show the compressed version, and then we get this number from 0 to 10 out. So those are the 2 different things. They are different beasts, so we have to be careful, right? And then what we did on top, we took a bunch of of metrics. In this case, it was 13, including things like PSNR, SSAM, simple ones, VMAF, these kind of things, up to heavily deep learning tuned metrics. We didn't touch those. We just took them basically off the shelf and ran them. That's important. And now we did this kind of comparison. First step, full pairwise comparison evaluation using the DCR data, because there we have a quality scale that we can use. It's not a comparative thing, so we can run that. So we use the Krasula method, which is basically just telling you 2 things. The first one would be there's an area under curve evaluation telling you how well does the metric distinguish between similar and different content. And then out of the set of those where the content would be clearly different, we would say, okay, so how is the classification rate for that? So this is basically the thing that we do. And then we come up with these 3 curves. And the interpretation is you have the area under curve here, you have the the classification rate and the area under the curve for the, so those two are for the set of let's say, easier to distinguish cases. This one is the overall differentiation, and then just all data, all metrics. And what you see here, the numbers are down here for the metrics, and you see the number 8 is the PSNR because it's blamed so much, and you see in this comparison it's really poor. Yeah, the PSNR is performing worse in this case, and the DASTS is working pretty okay, right? In this case, widespread. And if you just look at the other case, it's similar. So the PSNR is not the worst one, but it's still not so good, right? So we have summary, DASTS is best, PSNR is somewhere very low. Now we change the picture. We look at the data from the remote expert viewing tests. And so here we don't have the scale. We can't use the same method. What we did here is that we look at the correct decision rates, meaning that if you have a delta between the metric values and it points into the same direction as the delta from the subjective test, and then we simply count. That's how we do that. We have two cases. In one case, we look at the correct decision rate, just taking all the data as it is. Second case, looking at the confidence values just to see where we are. And so looking at this, we see those are percentages, and we see very similar set of metrics being best. Yeah, so we highlighted the 4 best in each case. Actually, we have, if you look a little bit closer, then it's 5 that are similar, because like here, AVQT is actually the next one, which is just not highlighted anymore. PSNR here is just also the next one, which is performing. So we have one group of metrics, which is SSAM, MSSAM, VMF, PSNR, and AVQT, which performed best. This is a totally different result from what we had before, right? It's a totally different thing. So that's interesting. Now let's look at the third dimension, and we compare the DCR and the CCR tests, right? So we look at the differences. We actually went for computing 2 different ways of how to treat the confidence intervals. And we had, this is a example curve. In many cases, they point into the same directions. The blue curve is the DCR difference. The orange curve is the CCR. Those are not living on the same scale, so we have to be very careful with the numbers. The meaning of the numbers for those scales is different, but the direction is the interesting part, right? And we see, but for the orange ones, they are more pronounced, maybe. Yeah, so that brings us to the conclusion that we would say, well, by concept, they are quite consistent. Yeah, so if there's a difference in the DCR, there's also in this similar direction for the CCR. The decisions for the remote expert viewing tests are a little bit more clear. This may be due to the fact that the experts are simply more motivated, or maybe more harsh. I don't know. Right? So they just tend to give a more extreme result, but the directions typically work out. We had one case where they're actually contradicting. That's here. That was a chemo sequence. This is something that we didn't fully resolve why that's the case. Okay, so major findings. The remote expert viewing did work. If you would translate that not to be remote, but just on the meeting, we feel that this should be giving us a reliable result. That's a very important result, because this means running such tests for decision making in the process should work out. Then for the metrics, this is something that needs to be investigated further, because the messages are so different. And one aspect that I think needs to be considered in this full pairwise comparison, we did the comparison of all possible metric points and all possible MOS points, and so we put that into relation. And PSNR is poor. But if you would look at how the PSNR performs on a sequence, then the delta on the sequence is much, much better, right? And this is probably the case why it's performing so poorly. So people have to be careful in that saying a metric would be good or bad, right? Quickly on the next one, totally different task here. The question is, how do we assess objects which are not like rendered by themselves? Right? So the video is clear. We have an input video. We have an output video. We could pixel-wise fidelity metrics. We can apply those, and then we're done. If we have point clouds, then we have a rendering process in between. So we don't measure, or we can measure in the point cloud domain, That's something that is actually done. But what people see is always going through a renderer. So what is the impact of those kind of things? And then the question was, does it make sense to evaluate on the geometry only? Yeah, so there was one experiment that was done. Let's please not argue about if this is the best way to represent the geometry only thing, right? Because I mean, this was the choice that was taken at the point in time. It's including the reflections, right? So the non-Lagrangian surface a bit, not too much, but this was basically meant to make people able to distinguish as much as they can the objects. Probably could do that a little bit better, but I think the main findings should be okay. And now, what we compared, we took those, we did an expert viewing at the meeting, doing an ACR test with hidden reference. Yeah, so people just see all the stuff they rated, they don't know what the reference would be, and then we get the results. And we have the three of the most favorite metrics that were used in the working group, who is working on the standard for that stuff, right? Now we did the same exercise as before, so we have the numbers from the ACR test, we have the objective metrics, we do the area under curve study, and we get this. Now just quickly saying the metrics. This is the left one is the geometry plus attributes, so that would be a rendered video that has been watched. On the right side, you see the geometry only. And maybe the most striking result is here, the metrics are ordered. PSNR is the last because the PSNR was taken out for the geometry only. There doesn't make so much sense because there's no texture to measure the PSNR on, right? And what it tells us, so we have the three metrics, D1, D2, and PSNR. Those are the ones that have been computed on the point cloud. And then the IB something are image-based metrics. So there, we just took the rendered video, we computed that on the area, just basically the area of the object, and compute a metric there from and we compared the metric to the uncompressed point cloud that has been rendered and the compressed point cloud that has been rendered. So they go through the same process, and then we do the metric computation. And so you see, first message maybe doing it image-based is not so bad, right? So you get very similar results. But then we see PSNR actually works surprisingly good. So it works well in general, and it works specifically if you go for the set, which is where the differentiation is more clear. We see that it's actually performing clearly better than all the others, right? And now if you go one step to the right and say, okay, now let's look at the geometry only, and we realize D1 and D2 are geometry only metrics. They only look at geometry. So them not to be so good, well performing on the full thing may be not a surprise, because that's somehow their property. They are only looking at geometry. But then if you look at geometry only, they are also performing bad. Right? And this is something which is really maybe astonishing for the first moment, but then we found out what might be the case. And the reason could be that actually these D1, D2 metrics do not consider holes in the point cloud. They simply skip the holes because they don't have data, so they don't compute. And this is not matching what people would say is the subjective thing, because if there's a hole, it's actually very, very bad. So, and this is the point. There's the D3 metric that would compensate for that, but this was not considered in the group. So this basically clearly tells us. So on the cases where we have data, the metrics work fine, but as soon as you have holes, the metrics lose quite a lot. So this is something that needs to be taken care of, and now then you have to convince the group that it's best to to really reconsider what they're using as a basis for their discussions. Okay. Yeah. Okay. Last part. We are building a data set for compressed video for study of quality metrics, CVQM. That's a process that's currently going on. The idea is we are in the advent of having neural network-based codecs being competitive with conventional video coding schemes. That's something that's, I mean, it's claimed everywhere. You look at the conferences, it's full of such statements, right? That they're so much better than VVC, so much better than HEVC. And it's fantastic, right? So let's see. I mean, it's if that happens, it's very cool. But the question is, how much does that hold if we put it into a test under our control, right? And this is basically what we do here. So we have a set of sequences. We try to somewhat cover a wide range of application cases. You see here those types. You see the SITI as an indication. So it's just a wide spread of things. And we split that into two phases. We started with HD sequences because so we did the call for that in roughly 1 year from now ago. That was in Hanover. And at that time, all the people said, "Oh well, we can do HD. We cannot do UHD sequences." Yeah. So we said, "Okay, then let's start with the HD sequences." That was 8 of those, some 8 bits, some 10 bits, which already imposes problems to the neural network-based codecs because they need to be trained for everything, right? Well, there we are. We have to face reality. We did DCR tests again. And we compared the following things. So we have the HEVC, where we take the test model, the HM. That's the reference software that's producing compliant bit streams. And is meant for evaluating tools. This is not something, this is actually something which I really want to stress. These reference software packages are not what you should do if it's about optimizing for subjective assessments. This is the software that is used to make rate distortion decisions. Yeah, that's basically taking the MSE, taking the rate, having the right lambda, and doing rate distortion optimization. That's basically what it does. And so it's not necessarily what you should do when it comes to quality. So we took the HM, and we took X265 as a often used software for the purpose of coding in real life, let's say. And we did the same for VVC. So we have the VTM, again, the test model, and we have VVENC, again, the software which is used for that thing. And then we have 2 neural network-based codecs that were submitted, MassCRT and NVC. I don't know if you can read it, but the names are spelled out there. And there will be a lot of information out in public, I guess, anyway. So if you can't read it now, you can probably read it very soon. We have 4 labs that participated in this test. And we are, the data is there. We are currently compiling it and releasing it. Now, there's probably I want to answer a question that you will probably be asking, is this data going to be available? I would say for MPEG, yes. For the outside, we are currently clarifying. There are multiple issues, and one specific issue is the licenses with the sequences. Because the sequences were selected not thinking too much about this licensing thing, and then we said, okay, oh, wait a minute. If we put out bit streams, or we put out compressed video or whatever to the public, maybe we are not allowed to do that, right? So we are figuring that out. Inside MPEG, it's okay because those sequences were given to MPEG for development of standards, and this belongs to that activity because we want to determine what are the right metrics there. But it's something that needs to be carefully thought of. It's something that we maybe should have asked before, but that's something that's how daily life is. So if you would have known before, you would have maybe done things differently before, afterwards. Phase 2 is going to be UHD because in the meantime, we have those 2 who submitted for phase 1 said, okay, now we can also do UHD. So that's just a difference of, let's say, half year, 1 year, something, and the increase in performance was there that they would say, now we can do it. That's very interesting, right? And we have a third one who's also saying, okay, we can also deliver bit streams. So now we have 3 learning-based codecs who volunteer to provide their data. And there's one issue. You see that number up there? It's 25. We currently have, we made the test setup with 25 UHD sequences. Now it's 7 codecs. It's 25 sequences. It's 4 rate points per sequence. This is a number that's impressive. So we need to see how we do the testing, and probably we'll narrow down a bit on the set, so that we can't test everything, at least at this point in time, because it's simply too much. Okay, so the current plan is that people would deliver their bit streams at the January meeting. So the neural network-based codecs for the standard ones, they are already available. I mean, it's not so difficult. And then we will do the evaluation, let's say, in Q1, Q2 of 25. We try to do that before a potential call for evidence activity really kicks in, and then this would also overlay with all those things. Okay, so this is something to look at, and then this will be very interesting. So you saw the studies that we did before, right? So this is something that we probably will do again. So we look at the metrics, maybe we follow them, like how do they perform on a single sequence, how do they perform over the whole set, all those kinds of questions, and then we will see what kind of conclusions we take, specifically if it comes to learning-based codecs, right? So how meaningful are those numbers? I mean, we can make a guess, right? It's whoever tried to compare a, let's say, a wavelet-based codec and a DCT-based codec knows what we're talking about, right? The metrics don't tell you so much. Within let's say one track, within the DCT-based codec, it's fine. Within the wavelet codec, it's probably also fine. But otherwise, it's not. Okay, I got a sign, but I'm also on my last slide, which is empty, which is good. So I talked a bit about MPEG, 85, what we are doing there, following the path through the standardization process. We looked a little bit into details of how the remote expert viewing tests performed and what the metrics tell us. And it's not a clear message, right? This is, I think, the main takeaway. If we look at that also for the immersive video, the example for the point clouds, and so we see that there's maybe some room for improvement, how to handle those. And we look at CVQM, this data set, where we are, I'm really excited to see the results of that, and then seeing that coming out. And I have a small advertisement that I have to do. Picture Coding Symposium, it's a place to be for everybody involved with coding. It's the oldest conference on image and video compression in the world, right? And we have the honor to have it in Aachen. I have the honor to have Angeliki as one of the program committee chairs, so that's very nice. Thanks for your attention. Oh yeah, I forgot to sell. Yes, and it's just on now, so you could even come like tomorrow. There's a train. I'm going on to be on the train to Aachen. If you want to join me.
I think there's a really good opportunity for MPEG to try and solve some of this rights issue around evaluation, because it's a big pain point for any kind of these activities, like having some test sequences that MPEG has solved and wrangled that rights with.
I mean, we have so this rights topic is really something that kind of it always comes from the side, and you say, hey, "Come on, guys! Now the technical side is fine. Now we have the legal side." We have Netflix did a great move with their open source data sets, right, where they simply say it's Creative Commons 4.0 something, and you can just use it, and it's so helpful for the community, right?
I think broadening that out, maybe MPEG even taking a stance on that, I think would be super useful.
Yeah, but it's actually difficult for us. I mean, we are in contact with owners, and sometimes they simply are not interested, right? So they say, well, we don't react or whatever. So it's something that's it's good once we have it. We just now got from YouTube, we get a set for user-generated data, which has the same license, which means that we can use it, and this is also very helpful. If there are other providers who may have interesting content, so if there are sources, yeah. Yeah, sure. Yeah. Yeah. Yeah, so it's really something. I think it's also for the general community. It's something where you just have free content, and if the free content includes sequences with faces, and it's okay to have those sequences published in a book or in a paper because there's a face on it. That's super good.
Yeah, I agree. I think it would also be important for producers to actually start releasing this test content like Netflix did, because also content evolves.
Yeah.
So we've seen that Andy shared a few things about new types of content. So yeah, that's really important as well. All right, Marta.
So I guess few of us in the room are the national body for MPEG, and we should have access to these results in a couple of weeks or months, I guess. When it comes to test sequences and more importantly the compressed video streams, do we also
Yes. So we
Already or
the sequences for HEVC and for VVC are already, the streams are already available in HE5, right? For the other stuff, this will be made available, and there we will make available the videos, because of the issue that the learning-based codecs don't reproduce on a different graphics card. So we have the bit streams, we have everything, but you will not be able to reproduce unless you have exactly the same setup. That's a big thing with learning-based codecs, since you have this, like you have all these temporal dependencies, so you have drift like hell if you're on the wrong platform. That's a problem that we deliberately said we don't solve that, because it's not about developing a standard here, it's about looking at the results, right?
So you will make available VQA files.
Yes.
And also subjective.
Yes. So the subjective numbers, the objective numbers. For the standards, we would have the bit streams. For the learning-based codecs, we would have the VQA files probably in a zip or so that they're a little bit smaller for download. I hear people from Far East saying they would appreciate very much to have a zip rather than the full file. If you're in a country where let's say the download speed is limited from Germany, then it's difficult, yeah.
Quick question. So the standards that you define in the tests, like, have you been changing them now with the AI-based codecs, or they are still like the same fundamentals and same tests?
So in that immersive thing that I was reporting on, that was a call for AI-based point cloud compression. That was a call that was evaluated in November, so like 5 weeks ago or so at the MPEG meeting. And that's the first standard of MPEG that will have AI-based technology, mostly for the geometry. So they're currently looking at different cases. One is AI-based geometry compression, and then having conventional compression for the textures. Some is also like looking for AI-based solution for that part as well. It's kind of playing or looking at what would be the best combinations, or what do we allow for in the standard, right? And the gains for the AI-based technologies are quite interesting. So that's why it's explored. I mean, you have JPEG AI, that's a still image compression scheme that already has been finalized, which is AI-based image compression. But the scale of that is not such that you would say, no, we can just pump that into a video, because video has very different demands in terms of what is the, let's say, the bits to pixel complexity and time that you have, right? And that's very different for video. To be able to have that in real time, everything stable, that's a different topic. Yeah.
Okay, let's thank Matthias. He will be around for further questions. Thank you very much, Matthias.
Thank you.